Hi, my name is Michelle Wood, and we're going to be talking about the mitochondrial electron transport chain. The electron transport chain is the process by which energy that is stored by electron accepting complexes, complex 1, 2, 3, and 4, that are located in the intermitochondrial membrane and the intermembrane space, are used to generate ATP. This is done through a proton gradient that moves from the mitochondrial matrix into the intermembrane space. So we start with NADH, which was generated in the citric acid cycle, and that donates 2 electrons to complex 1. This supercharges complex 1, which is a proton pump. So now it's able to pump the protons from the mitochondrial matrix into the intermembrane space. The donated electrons go from complex 1 to coenzyme Q. Coenzyme Q holds onto those electrons. FADH2 donates 2 electrons to complex 2. Complex 2 is not a proton pump. It transfers these electrons directly to coenzyme Q, at which point coenzyme Q donates all these electrons to complex 3. Complex 3 is a proton pump. It is able to shuttle protons from the mitochondrial matrix into the mitochondrial membrane, just like complex 1. Also 4 hydrogens for each one. The electrons that come from coenzyme Q and that go into complex 3 are then transferred to cytochrome C. Cytochrome C transfers these electrons directly to complex 4, which pumps protons from the mitochondrial matrix into the intermembrane space. The complex 4 only pumps 2 protons per NADH or FADH2. Water within the mitochondrial matrix then splits and becomes oxygen that is in the mitochondrial matrix then splits and becomes 2 oxygen ions. Hydrogen is 4 hydrogens are donated to these oxygens, making 2 water molecules. ATP synthase is activated by the electrochemical gradient that is created by the influx of protons in the intermembrane space. Then it transports all those hydrogens, 34 hydrogens in total, and pumps them back into the mitochondrial matrix, at which point ADP plus pi is given enough energy to phosphorylate and become ATP. And that's it.